Okay, so I'm essentially going to walk through this lesson I've put in the week 6 repo. I'm sure Katie told you this, but in this lessons folder, if you open it in the browser, that's how you can view the nicely formatted lesson plans. So that's what I'm going to keep going back to today. So Shiny, it is an R package that lets you build interactive web applications. And you can host them as standalone apps. There's also ways you can embed a Shiny app in an R Markdown document. So if that's something you're interested in your final project, let us know. We can help you work through that. It's a little more complicated, but definitely doable. And like I said, you can do it all within R, and you can create a website without needing to know any HTML or CSS or JavaScript. You can do it all in R. So for this demo, there's so many things you can do with Shiny. As you saw, there's a lot of widgets. There's a lot. So I'm going to work through kind of a very basic application just so you can see how the structure and the setup works. And then there's a bunch of resources for like deciding which widgets you want to use and things like that. Or there's a ton of different layouts you can choose and themes and stuff like that. So for this example, I'm going to use data you've used before from the Geospatial Week because I'm going to make a map. So I'm going to pull the species occurrence data that we retrieved in week 4 because that's a good example because across the state there's just a lot of points. And when you make a map at first, it's kind of just mumbo jumbo. But with the Shiny app, then you can filter out things. You can filter which species you want to look at. We're going to filter which elevation. Like I just want to see occurrences above 2,000 meters. I think I have meters, etc. So that's what we're going to use for this example app. But a little background on the structure of Shiny. So you create a Shiny app in a single script that has to be called app.r, all lowercase app. Within that single script, there's 3 main parts. The first part is the user interface or the UI, or I call it the UI. This controls the user interface. It controls the layout and the appearance of your application. So this is where you specify those widgets that users get to interact with. You specify like if you have a time slider, the range of dates, things like that. The layout of your application. Do you want a side panel? Do you want a map output? Do you want a plot output, etc.? All of those are specified in the user interface. And then second is a server function. And this contains the instructions needed to build your app. So this is more of the R code. So basically, if you say, I want to have a map here in the server, that's how you'll have the code to read in the data, clean the data based on what the user wants, and add it to the map. And then once you have the user interface and server defined, then you run this function Shiny app. And within that, you specify what your UI object is and what your server object is. And we'll see all of this in a second. Okay, so if you want to walk through with me, we can work in the week 6 repo that you have forked and cloned. And I think, I didn't do it on this computer. Okay, so to make a new Shiny app, kind of the easiest way, you can just write an app script from scratch, but there's an easier way that'll give you a template. So we go to File, New File, and click Shiny Web Application. And then this will pop up. I'm just going to call it, I think I already made one. I'll call it Shiny Demo. I don't have that on this folder. Keep the default. There was an old way where you would have a separate script for the UI and a separate one for the server, but the new method is to just put it all in one. You can still use the old method. I prefer having it all in one app script. Keep it single. By default, it's going to put this in your project directory, so I'm just going to leave that there, but you can change it if you want, and then click Create. And this will actually create a folder in your project directory with the name that you just gave the web application. So the reason it puts it in a folder is it's kind of just, it's good practice when developing web applications for the code and data and everything to be self-contained, because that makes it easier to, one, share with others. I can just share you this folder. You can open it, run the script, and the app will open. Also, when you are deploying applications, having it all contained in one folder makes it easier for deployment too. So it creates this folder, and then it created a template app script. Oh, and it opened it up for us too. So if you open this, I'll exit that one. It gives you a little info, a link if you want to learn more, etc. By default, I'm pretty sure when you create a Shiny web application like this, if you don't already have Shiny installed, it installs it in the background. And then it calls Shiny at the top. Although if you try and run this and it says error, Shiny doesn't exist, you might need to install Shiny. But the only package you need to use Shiny is the Shiny package. I feel like there was one more thing I wanted to say. Oh, and another important thing is that these app scripts are self-contained, and when you run the app script, it assumes whatever folder that script is in is the working directory. So we'll go through in a second, but like if you want to add data, you have to put the data in this folder. So actually, this template, let me just move over a little bit, is a full Shiny app that we could run right now. So kind of just look at the structure. We define the user interface, call it UI. And then second, we define the server. And this function input output is always consistent. Really, the only thing you need to, or that we will change, is the content within the server function, and then also the content here. I'll go through that in a second. And then lastly, to run the application, we use this Shiny app function, and we tell it our UI is the UI object we created, and then server is the server function we created. And so there's different ways you can execute. You can source this whole script. You can run these chunks individually, but I always just click run app. And then you can, I think by default, it'll open in a new window. If you click the down arrow, you can click, if you want it in the viewer pane. Run external will pop it up in a browser window. I'll just keep it as run in window. And you can run application. Did anyone get an error that said Shiny not installed? Cool, so I think it does install that. And here's this template Shiny application. So it's very simple. It's using some pre-installed data, and then this widget is telling it what bin size to use for the histogram. And then if you ever want to look at it in the browser, you can click open in browser, and then it'll open it in the browser tools too. So this process of viewing this app, where were we? I will make changes to my app script, and then I'll just keep hitting run app to see the changes, and it runs pretty quickly. But this isn't publishing it or anything yet. This is just loading it on your local computer to view and mess around with. The functionality is still fully there. Okay, so for this demo, I need coffee. Okay. We open that. Okay, and then this is breaking down the structure of the script here. So fluid page is a layout option. Essentially, this is just, probably most of your apps will start with fluid page. It's saying, I want to create one page, and everything is fluid, meaning it's going top to bottom. In this lesson, I have a link somewhere for the different layout options. Oh, it might be further down. We'll get there in a second. But within it, we specify title panel will go at the top. So this is going top to bottom since it's fluid page. And then we're specifying sidebar layout. This is where there's a link I have in the lesson later of the different types of layouts. Within this, we specify a sidebar panel. And then this is what's called a widget. I think there's other terms for it, but I always use widget. So this is, we want a slider input widget. And the most important thing here is this first argument. I think in the demo code I specify it's called input ID is what that first argument is using. But this ID name is very important because this is needed in the server side to pull what did that user specify in that widget that I need to change the data to. And so this naming should be like normal coding naming structure, no spaces or anything. And when you're calling it, you have to spell it exactly right. Then in our main panel, we have, this is where we're specifying instead of a widget, an output we want to see. And there's different types of outputs as well. Plot output will output a plot. In our example, I think we use tmap output because we want a tmap object. We'll come back to that in a second. And then here is an example of where we use those input IDs. So now in the server, when you want to create an output, you do output $, the name, the ID you gave the output. So this is where ID is important again. The output was called displot. Now we want to create this output called displot. And then we use a call render plot. So I know this is kind of a lot of new syntax, but the structure is similar. Really, it's just the types of outputs you'll be changing. Like if you wanted a table, it would be render table. And there's a lot of resources. I've linked some back in the GitHub too for finding these. So when we're rendering the plot, here is where we're specifying bins. And this is where it's calling input call it bins. So when it does input call bins, it's calling whatever user selected in this widget. So if they picked 20, then it will replace this with 20. And so this is the thing that's changing based on the user input. And then it uses bins here to create the histogram. Okay. So a little bit on the structure. Now let's make our own. Okay, so I've put this data in the week 6 repo. So if you forked and cloned, it should exist. It's called Shiny Demo Data. In the project directory, it's in the data folder. Now remember that the app runs from whatever directory it's in. So let's move this to our new Shiny Demo folder we just created. So there's different ways you can do that. You can do it from your File Explorer, or you can do it from this Files pane. So I'm going to check it. And then, oops, I need to move this over. Isn't there a more button? Oops. Oh, here we go. Settings, and I'm going to say copy to. And I want to move it to that Shiny Demo app folder I just created. And I'll just put it in the folder. You could put it in a separate data folder within this, but for this example, I'm just going to move it there. And now if I go back to the Shiny Demo app folder, now it's there. Okay, so at the beginning of, we're basically going to take this app file and just delete the stuff that's already in there and add what we want. I'm just going to take out this extra text. Okay. But first, you can follow along with this if you want. I just wanted to kind of bring back up, oh no, oh yeah, we're up here. I just wanted to bring back up, remind you what this occurrence data looks like. So in my current R session, I'm just going to copy this. You don't have to follow along with this if you don't want to. I just want to, or you can run it from the RMD. I just wanted to read in the occurrence file and show you what we're working with. But also, since these app scripts are totally self-contained, at the top of it, you'll always have all the libraries you need to run all of the code in the app script, and then also any data you want to read in. That will all happen at the top and set everything up. Okay, so we have this occurrence object here. I saved this as a .r data file. So when I read it in, it's read in as whatever name it had when I saved it. So we're working with awk again. And it is saved as a SF point object, so we don't have to convert it to an SF object or anything. And then we have these attributes. So we have for each occurrence what species it is, when it was collected. Basis of record is how it was entered in the database. Was it a human observation? Actually, I think we can look at unique basis of record. So we have human observation, preserved specimen. These are occurrences that were saved probably in like a museum back in the day and was finally digitized and uploaded to the database. Or a machine observation. I believe these are all like iNaturalist observations. That's a machine observation. One thing about GBIF is it pulls regularly from iNaturalist data, which is pretty cool. Okay, and then we also have elevation. So for each point, we extracted from our elevation raster the elevation in meters at that occurrence. So we can use all of these attributes as widgets to let the user filter the points by these different attributes. Okay, so first and then I was going to run this. Actually, if I go back to, I have this open. I also just wanted to show you what it looks like on an interactive map. Because normally when you start with a Shiny app, you will make, the maps or the plots or whatever in R. So you have the base code to create that map or create that plot. Then when you bring it into Shiny, you Shinify it. So this is the map we want to make in the Shiny app. We want to add widgets to let people filter what points are shown on this map. So this is the chunk of code we're going to be putting in the server, but we'll need to mix it up a little bit. Okay, so now let's actually make our app script. So under getting started, we already moved the data file. And now we need the setup. So to do this, we need tmap, SF, and we need the dplyr package, because we'll see later we are going to be, based on the widgets, we'll be filtering that occurrence data set each time a user interacts. So we need the dplyr filter function. We're going to load in this R data file, and then we're going to set tmap mode to view because we want to make an interactive tmap. So I'm just going to copy this chunk and go back into the app script, and I'm going to put all of this under Shiny, because we do need to have library Shiny always at the top. Okay. Now, for the user interface, here's where I have more layout options. Oh no, I want a new window. But this link is if you want to see, so like a sidebar layout is what we're using, a side panel, a main panel, tab set panel if you want tabs, and then it shows you what that layout looks like and the code you would use. So this is a good resource. But we're going to stick with that same layout for this demo. We're going to stick with the fluid page. We just have one fluid page. Let's change, wait, do I have the title? Oh, I went to the new link. Okay, so I actually just wrote all of this code for us just for the sake of this demo. But I have comments about what each section is doing. So I'm adding the app title. We're keeping the fluid page. H5, we can use HTML tags in Shiny. So H5 is actually a level 5 header, similar to a level 5 header in R Markdown. So I just want a smaller header under the title panel. Since this is fluid page, it will put it right under the title panel. And then under that, it specifies, we're going to keep the sidebar layout. And now we're going to add 3 widgets. So we're using a new one here called checkbox group input. This will make a checkbox widget where you can choose which species are on the map. Again, this input ID is super important. Label is the title that will go on the widget. And once we make this, you'll start, realizing where these things go in the app space. Choices are the choices you'll have for the checkboxes. If your choices match up, are spelled exactly the same as how they are in the data frame, you can just use choices. If, for this second example, we're doing a checkbox for which type of observation you want to see on the map, we saw in the data set, these are all caps and underscored, but we want them to look more like human written on the app. So choice names, you would specify what you want the name to be in the app. And then choice value, that's the actual value it is in the data frame. And these have to be in the same order as each other, like human observation. And then it'll essentially creates a paired list. And then selected is what checkboxes you want selected by default. So by default, I want all of them checked. I want everything on the map. And then the third is a slider input, which is the same input that we saw in that geyser data for the bin size. And here, the difference is compared to the previous code, we have a slider input, we have a min and a max set, but they just wanted you to choose one value. If you want them to be able to choose a range, you give it a range. So that's the only small difference. But within concatenate, we have the minimum and maximum. This is the default we want to have. We'll see, but we'll have the slide. We want the left slider all the way on the min value, the right slider all the way on the right. But if you wanted the default to be a smaller range, you would change these two numbers. But it will still allow you to slide it to the minimum and maximum. And then in our main panel, instead of plot output, we use tmap output. Because we're making a tmap object, and I'm just calling this map. So for this demo, I just want you to copy this whole chunk and replace it with the current chunk. And in Shiny, this is where rainbow parentheses really come in handy because there's a lot of nested things and a lot of brackets and parentheses. And if you don't close one, it'll sometimes throw you an error and you'll have no idea what the error is. So whenever I try and run the app and it doesn't work, that's the first thing I look at is, did I close all the brackets correctly? This is where the rainbow helps. So I'm just going to delete and paste the chunk I just copied. So now we have our new user interface defined here. Okay, second is the server. This is where things this is kind of all probably really complicated, but this is where things are maybe the most complicated. So we want to use that same TMAP code we just used to make that interactive map. But within that code, the thing that's changing is the occurrence data that we're loading in the map. And when you have a variable that is changing based on user input, this is what's called a reactive variable. And so first, we need to define this occurrence data set. We need to filter it based on the user inputs. So the first thing we do is define the data that's going to be shown on the map, and then we show it on the map. Since this is a reactive element, normally we would take our occurrence data set and filter it by what did the user check for species, what did the user check for type of observation, and what did they check for elevation. So it's doing a bunch of filtering, but since this is a reactive object, we put it within reactive as the name of the function. So that whole chunk of code goes within reactive, and I'm going to call this occurrence block react. And then again, this is where that ID name is really important. So here we're filtering species column that is within input call up species. Within checkbox group inputs, it'll return every choice name as a list of names or a vector of names. So that's how we can use the in argument here, and then same with input. And then with elevation, the little difference here is since we have two values, we can index. This is why indexing was taught on the first day, because it always comes back. And since it's returning a vector, single brackets, so the first index will be the first value on the left slider, and then the second index is the value on the right slider that's chosen. And so this is why we're filtering. I want everything greater than that chosen minimum value. I want everything less than that chosen maximum value. Okay, so we created that reactive object. Now the second tricky thing, so we're still calling output call up map. That was our ID name we gave it. And now instead of render plot or whatever it was before, it's render tmap. And these are all package specific functions. So like I use leaflet a lot. And so I'll check, what is it? Render leaflet? It is. Is it a capital L? It is. But I'll check that specific package to make sure that function name is right. And now when we want to, first thing we do is add that occurrence data set. When you're calling a reactive object, you have to end it with these open parentheses. This is also something that I will forget to do, and then it's hard to find. It might even say occurrence react doesn't exist. It might throw a nice error, but sometimes it doesn't. So that's the second thing I always check. Did I have the open parentheses at the end of my reactive object? So these are the quirks of Shiny. And the rest of the code is exactly the same that we made to make that map. The only thing changing is the occurrence data set. And then I also added Rocky Mountain National Park boundary just for fun, but that's not changing. So that'll always be on the map. Okay, so for efficiency, we are just going to copy this whole chunk, go back to the app script, and I'm going to delete everything, pink bracket to pink bracket, and then paste the new server. Okay, after that, everything is the same. We still have the same Shiny app call because we still named user interface UI and server. And now if we run app, hopefully this works for everyone. If not, we can get to errors in a second. We're almost done. Okay, so now here's our app. Map might take a little bit to load. So the map is still the same, but now we have the side panel with the widgets. Now we can, let's say we just want to look at elk. And you'll notice that every time it'll blur out a little bit because it's recreating the map. There are ways, it's just too much to get into for this demo, but there are ways you can prevent that from happening using things called a map proxy. We won't get into that, but there's ways to address that if you really want to get into Shiny app development. So now we see all the elk observations, and so I just want to see the ones above 3,000 feet. Cool. And then it filters those out. And then I left this so we could compare it with it and without. Oh, that is I think that would work. Let's try it. There's other things called a z-score or z-index that you can specify within. I know you can do it within Leaflet. It might be a little bit different in TMAP. But that specifies layer order. So that's just another argument. We could try. Or you can also change I think that's why I set the alpha level. That's the transparency. So you can still see the points underneath. But I think there's a way. We could do that. Real quick. Oops. T-map shape. And this is when I use Control-Shift-A. Did I teach you that trick? The Control-Shift-A formatting thing? I think I did it in our tips and tricks, but when I'm like rearranging things and the format's ugly, Control-Shift-A. Okay, reload. Yep.
Do you need to add a plus at the end of TM polygons to get it to read through to the next part?
Oh, and so that now it's shift order.
On the TM shape off React. Do you need a plus sign?
Here?
Yeah. Okay.
Yes. Yep. Otherwise, I don't know what it wouldn't put them all on the same map though. I think it would stop there. Yeah, so TMAP is another weird one like ggplot where you add elements with a plus sign instead of a pipe. That's why I like Leaflet better too, because you can pipe instead of plus sign. But TMAP is actually, you can tell, is using Leaflet map. It's just a different package. Okay, so that is the extent of this demo. The next part that you would want to know is how to share the app. So I have some resources down here. Also, the Shiny cheat sheet is really nice for looking at things like the widgets you can use, layouts available, and then the Shiny gallery is really cool. It has a bunch of Shiny apps people have made and links to the code on the back end. But there's a lot of options to host it. You can also share your application. This is why it being contained in a single folder is nice. So you could package up zip this folder and share it with anyone, and all they have to do is read it into RStudio, click Run App, and then they can interact with the app. But if you wanted to host it and have an actual URL, maybe the easiest way, there's different options, but it's through shinyapps.io. You can create a free account. And then I have this tutorial. It's a little more involved, so I'm not going to go through every step, but you have this tutorial. If you want to do this for your project, just sending us the folder is fine. You don't need to go through hosting it. But if you want to, you can do a free account on Shiny Apps. The free account is just limiting you to how much like RAM power, how many users can use it, and then also how many apps you can have. But like, for example, this is what it'll look like on the back end. This is we have a Centroid Shiny Apps account that we host these apps. And then what you do, I won't pull up tokens, but actually, I think RStudio walks you through this really nicely. So you'll see this publish thing up here. This is how you publish your app, but you need to have your shinyapps.io account hooked up. And to do that, under Tools, Global Options, publishing, this is where, say you made your account in shinyapps.io, you would click connect, shinyapps.io, and then it tells you how to do this. You would log into your account, find tokens, copy the token, paste it here, and click connect. That's the only step you have to do, and then every time you want to hit publish, it's already connected to your account, and it'll publish. I'm not going to publish this now because we don't need it. And yeah, I think that was the end. So let's